I hope I am audible to you. I hope I am audible to you and screen is
Yes, sir.
visible to you. We have started linear programming problem in the last class. Linear programming problem, its formulation, how to convert a given problem to a mathematical formulation or linearity means first degree equation. Linear means first degree equation represents a straight line. Programming means it's a planning. So planning here, what amount of product and B, that is my X and Y to be produced so that we can maximize the return with the minimum cost, minimum usage of the available resources. So this is the aim of the problem. Now this is the next question. How to convert? Already I did around 4 questions in the last class. So this is another question. This 1B01 Rishi has come and now he left. Okay.
Sir,
Ah,
sir,
1B
ரெண்டு டிவைஸ்ல வந்தேன் சார், ஒரு டிவைஸ் ஐ லெஃப்ட் சார்.
ஏன் ஒரு டிவைஸ்ல வந்து
சார் இன்னொரு டிவைஸ்ல ரொம்ப ஹேங் ஆயிடுச்சுன்னு தான் சார்.
okay. Now let us start with this thing. A farmer has 100-acre farm. First list out what is given, then automatically things will fall in line. So farmer has 100-acre farm. He wants to sell tomato, lettuce, radishes. Whatever he cultivate. The price obtained on tomato 1 rupee per kg, 0.75 paise per head for lettuce and 2 kg for radishes. Average yield per acre is 200 kg for tomato, 3000 for lettuce and 1000 kg for radishes. Fertilizer irrespective of all the three is 0.5 kilogram. So 0.5 kilogram, 0.5 per kilogram. Amount required per acre is 100 kg for tomato. Tomato requires 100 kg, lettuce require also 100, and radishes it requires only 50 kg. The labor for sowing, cultivating, harvesting per acre in 5 man days for tomato, radishes, 6 man days for lettuce. So 5 man days takes to tomato and radishes, 6 man days for lettuce. So total available man days will be 400, and the labor cost irrespective of all the three will be 20 rupees per man. So we want to formulate this problem to maximize a profit. So what are first given? What are first given to us? 3 components: tomato, lettuce, and radishes. So I do not know how many acre of land to be allocated. I don't know what amount of acre to be allocated for the 3. That is TLR. So that is B, X, Y, and Z. He is having 100-acre farm. In 100-acre farm, the farmer doesn't have an idea what amount of land acre to be given to tomato, lettuce, radishes. That is unknown, basic unknown. So then only he can cultivate, then only he can maximize. Suppose if he cultivate less land where he gets more profit, then it is a loss. So he should organize the acre of land which gives more profit. So first sentence what it says, he is having availability. He is having availability 100-acre land. He is having 100-acre land with him. So he doesn't know how much to allocate. So that is a problem. So he is having 100-acre farm. The ratio for tomato, lettuce, radishes is yet to decide. So that ratio is not given, therefore it is 1:1:1. So the ratio of tomato, what amount to be given to tomato, what amount of acre of land to be given to lettuces, radishes, that ratio is not given. That is why we say it is 1:1:1. The first sentence, he is having 100-acre farm. So this is a space constraint. This is a space constraint. What is the next thing? Selling price. Selling price per acre. Selling price rupees per kilogram, which is given. How much it is given? 1 rupee for tomato, 0.75 for lettuce, and then 2 rupee for radishes. And average yield. And average yield for tomato, how much it is given? 2000 kg. So for 1 kg, it is 1 rupee. For 2000 kg, it is 2000 into 1. That is the selling price. So 300 heads, which is given for lettuce. Whereas 1000 kg, which is given for radishes. This is a third sentence. Here it is. Here it is. What is the next sentence is fertilizer cost. Fertilizer cost per kg. Irrespective of all the three, it is 0.50 per kg. Per kg 0.5. So how many kg is required for the tomato? Fertilizer required for tomato is 100 kg. So for per kg 0.5. For 100 kg, it is 100 into 0.5. Likewise, it is also 100 as per the sentence. This is given here. And then last one is 50 kg. So this is given here. What is the next sentence? Labor required. Labor requirement. How many labors are required for tomato and radishes? Tomato and radishes 5 each. For lettuce, it is 6 man days. What is the labor cost? Labor cost, irrespective of tomato, lettuce, radishes, will be 20 rupees per man. So this is a problem. Have you first understood what is given? Have you all understood first what is given?
Yes, sir.
Yes, sir. So look at this. We want to maximize a profit. So profit is equal to what? What do you mean by profit? Profit is equal to selling price minus expenses. What are the expenses is he having? One is labor cost, another one is fertilizer cost. So fertilizer cost should be subtracted for all the three, and labor cost should be subtracted for all the three, so that you come to the first case. Profit is equal to, what is the selling price for? This is for tomato. Whatever I do, this is for tomato. Likewise lettuces, likewise radishes we want to do. Now you tell me, for tomato how much it is required? What is the selling price? 1 kg is 1 rupee. 2000 kg will be 2000 into 1. This is the selling price for tomato. Minus, what is the fertilizer cost? 1 kg is 0.5 for tomato. For 100 kg, it is 100 into 0.5. What is the labor cost? For 1 day, it is 20 rupee. For 5 man days, it is 5 into 20. So subtract this 5 into 20. So this is a profit which I get for tomato. This is a profit which I get for tomato. But for 1 acre, I will get this many. For 2 acre, I will get this many. I don't know how many acre to allocate. That is why it is X acres. Do you understand this? Have you understood this part?
Yes, sir. Yes, sir.
Plus, for the next case, lettuce, 1 head is 0.75 selling price. For 3000 heads, it is 3000 into 0.75 minus the same 100 per kg. So 0.5 per kg. For 100 kg is required for lettuce, therefore it is 100 into 0.5 minus how many man days is required for lettuce? 6 man days. Per man it is 20. For 6 days it is 6 into 20. but we don't know how many acre of land to be allocated for lat uses. In the same way, radishes. So the radishes, it is 1 kg is equal to 2 rupee, 1000 kg will be equal to 1000 into 2 minus fertilizer cost. It requires only 50 kg. So 50 into 0.5 minus what is last one? 5 into 20, am I right? Times of Z. So this is what required for radishes. I forget to tell one thing. What is the total man days available? Total man days available is 400 days now.
400.
So 400 man days will be availability. So this is for availability. Now if I simplify this profit, I will get 1850 times of x, 2080 per acre. But we don't know how many acre to allocate. So we have to solve this problem then only, but you don't want to solve now. They just asked to formulate the LPP. What is the first constraint? A space constraint. This is the first constraint, that is 1 acre of x plus 1 acre of y plus 1 z is less than or equal to 100 acres. First constraint. Second constraint is labor. 5 man days is required for tomato, but we don't know how many acre of land to be distributed. 6 man days required for lettuce. 5 man days required for radishes. All add together, it should be within 400 man days. So these are the two constraints which are given to us. Therefore, what is the last one? Non-negative constraint. X, Y, Z must be more than or equal to 0. Have you understood?
Yes, sir.
இந்த கொஸ்டின் எக்ஸாம்க்கு வருமானாக வராது. இனிமேல் போடுற கொஸ்டின்ஸ் எதுவும் எக்ஸாம்க்கு வராது. The first 4 questions பார்த்துக்கோங்க. The first 4 questionsல anything can come to exam. The first 4 questions, anything can come to exam. These questions are something advanced questions which you can get in MBA, advanced MBA courses like Delhi University, Sriram College of Commerce. If you want to do economics, econometrics for higher studies, where you will have this kind of problem in the fundamental. When you go to advanced studies, this kind of problem only will come. So consider the following problem faced by a production planner in a soft drink plant. He has 2 bottling machines A and B. A is designed to produce only 8 ounce. 8 ounce means it is a kind of measurement. B is designed only for 16 ounce. So mission A produce only 8 ounce bottle. Mission B can do only 16 ounce bottle. So what is the processing time to produce 8 ounce bottle on A, 16 ounce bottle on B, which is given. So mission A produces 8 ounce bottle 100 per minute, whereas 16 ounce will be 40 per minute. The B can be for 60 per minute, 75 per minute. So here, however, each can be used for both with some efficiency loss. Some efficiency loss would be there. But though it is produced for 8 ounce and 16 ounce, A is only designed for 18 ounce. Sorry. A is designed only for 8 ounce. B is assigned for 16 ounce. It is exclusively prepared, but they are using for both the types with some loss of efficiency. Though it is specialized in these production, but we are utilizing for both. That is why there is a loss in efficiency that is stipulated. Mission can run 8 hours a day, 5 days a week. So we should convert everything in terms of minute. These are all given in minute. So this must be converted to a minute. Profit on 8 ounce bottle is given 15 paise and 16 ounce bottle 25 paise. Weekly production cannot exceed 3 lakh ounce. So this is a production constraint. These two are the marketing constraint. Market absorb 25,000 ounce bottle, 7,000 16 ounce bottle per week. So everything is given in ounce. So maximum is 3 lakh ounce. So everything should be managed within this. So the planner wants to maximize a profit subject to the given constraint to all production marketing constraint. Just formulate LPP. So you know what is given. So mission AB, this is a very direct question. This is 8 ounce bottle. This is 16 ounce bottle. So for A requires 100 per minute. B requires 40 per minute. In a 1 minute, they can do 16 ounce bottle. Likewise, in a given 1 minute, a B will produce a 68 ounce bottle. In a given minute, B can produce 75 16 ounce bottle. Now you come to availability. What is availability? 8 hours a day, 5 days a week. 8 hours a day, 5 days a week. How do you compute? It is, we want to convert into a minute. How do we convert this into a minute? 8 hours a day, 1 hour is equal to 60 minutes. So 8 into 60 into 5. Am I right?
Yes,
We
sir.
want to convert into minute. So you know 1 hour is equal to 60 minutes. So 8 hours will be 8 into 60.
2400, sir.
Okay, this is 20, irrespective of both the case, it is 2400. Irrespective of both the case, it will be 2400. It is not exclusively for returns. Sorry, AB. Now profit, what is given? What is the profit? It is 5 rupee. Sorry, 15 pies for returns, 25 pies per bottle for 16 ounce. The production constraint which is given. Production constraint. What it is? For 8 tons, it is 1. Maximum, sorry, for 8 tons, it is how much they are telling? Weekly production cannot exceed how much? 3 lakh. So 3 lakh for 8 tons and 16 tons. It should be within, because everything is given in the unit of 16 ounce. So the ratio, you can assume it is 8 and 16 because all are given in this unit. Have you understood this? Production constraint is given for maximum how many you can produce. Weekly production cannot exceed. So this is a maximum. So for 116 ounce, 1 into 16, 216 ounce, 16 into 2. So everything is given in this unit. So already my assumption in the given unit, therefore it is 8 and 16. Is that clear?
Yes, sir.
What is the last two constraint? Marketing constraint, where it is. Market can absorb for 1 8 ounce bottle. This will take only 25,000 8 ounce. Minimum or maximum? Market demand. Demand means it is minimum. Market absorb minimum. That is market demand. Demand always given in this symbol. Availability always in this symbol. So these two are availability. These two are availability. This is a market demand. So for 1 8 ounce bottle, no 16 ounce bottle, it can absorb 25,000. For 1 16 ounce bottle, no 8 ounce, it will absorb 7,000 minimum. So this is what given to us. Now we have to construct a mathematical model. What is the question? The planner wants to maximize his profit. He doesn't know how many units of 8 tons and 16 tons to be produced. Let x comma y be a number of 8 and 16 ounce bottle to produce. Bottles to produce. So for 1, it is 15 pies. For 2, it is 2 into 15 pies. For X, it is 0.15. Likewise, for 16 ounce, it is 0.25 into Y. Both added together, we want to maximize a profit. Any questions? Have you understood this?
Yes, sir.
So far, you cannot take this as 100x plus 40y is less than or equal to 2400, because clearly see in the given minute, this is given for per minute. So in the given 100 minute, sorry, in a given minute we can produce 100. So in the given 100, I don't know how many to produce. Your machine having a capacity of doing 100, maximum 100. Machine A do 8 ounce bottle in a given minute, how much it can do? 100. It can do 100, but I don't know how many to produce. But it is having a capacity of producing 100 per minute, whereas 16 ounce will produce a 40 per minute. I do not know how many. Both added together, it should be within 2400. Do you understand? Why didn't I take like this? Why are we taking like this? As per the given, your 8 ounce bottle to be produced by machine A in the given minute, how many it can do? As per the given 100. 100 it can do, but will we go with all 100? Still we do not know how many to produce, but machine having that capacity. So we have to decide where I put more, so that the efficiency should not be lost. At the same time, we have to produce more. Also, we want to maximize the profit. Can you able to understand?
Yes, sir.
Without loss of efficiency, we want to decide efficiency. We want to decide where I want to produce more. Production should be more. Also, profit must be maximized with the minimum availability. With the minimum availability. Now you come to the problem. Machine A can do 100 8 ounce bottle in a given minute, but I do not know how many to produce. Machine B can do 40 in a given minute. I do not know how many to produce. Both added together, it should be within 2400 minutes. First, is this clear? Why didn't I take like that? Why are we taking like this?
Yes, sir.
The same way, what is the second constraint? In the given 100 minute, it can do, sorry, in a given 60 minute, it can do 60, but I don't know how many to produce. In the same way, in a given minute, it can do 75, I mean machine B, but we do not know how many to produce. Both added together, it should be within 2400. And this is another constraint, production constraint. So 1 unit will be 8 tons, 2 unit will be 16 tons. So X units will be 8 into X. This is 16 into Y. Both added together, I should have within 3 lakh tons. So far, we discussed availability. Now that market demand. So for 1 8 tons, I should have minimum 25,000. Likewise, for second constraint, I mean market demand, it will be minimum 7,000. Your X and Y are non-negative. Both are more than or equal to 0. Have you understood? Non-negative constraint. Any questions? Put forth your questions. Ask doubt. Shall I go to next question? You don't worry, this kind of questions will not come, but it will come only when you go for advanced studies. Like IIM, MBA from PGDM from Harvard, Stanford, NUS. If anybody wants to do, you can expect this kind of questions. This model, not exact questions. It is another question. Urban planning. So this is another problem. Urban planning. How are we using this linear programming model in urban planning? First, read the question, extract one by one, then you can understand. A city is faced with a severe budget shortage. Some city faced with a severe budget shortage, seeking a long-term solution with the city council. What they suggest, we want to improve the tax base by condemning inner city housing area, replacing with a modern development. So they want to condemn the inner city area, means already they are having a housing area that should be demolished, and they want to reconstruct, but they are not going to demolish all the building. They will take only the building which are not in a standard structure. Substandard building, if any is found, they can demolished. They can be demolished, where they want to bring this modern development. So that is a idea behind this project. Once if you bring the modern development, automatically we want to generate the fund, finance. So how will they get the finance? By borrowing fund. Another one is available fund. Borrowing fund, we can get it from any World Bank or any trustees like that. But how do you generate the money? So only thing, we want to increase the tax. So where can you increase the tax so that we will get we can improve the city, also the budget shortage can be reduced. So that is a main objective of this problem. He himself says the project involves two phases. One is, first we want to demolish the substandard houses, as I said, so that we can provide the land for the new development. And second one, building new development, the following summaries. These are the constraint, objective, everything is given here. So first, have you understood what is the objective of the problem?
Yes, sir.
Urban planning, some city is there, they are having some budget shortage, they want to demolish some housing area where they want to bring a modern development. How are they going to demolish the building? They are not going to demolish all the building. They will demolish only the houses which are not in a standard form. Substandard houses will be demolished. So we want to identify. Then we will bring the new development, where we will look at this many conditions, constraints are given. So let us start this problem with first thing. I do not know. Let us read out the questions completely. As many 300 substandard houses can be demolished. Each houses occupy 25 acre of land. Every houses occupy 25 acre of land. As many 300 houses means you can demolish 300 houses. Not exactly 300. I mean, you are given with 300 houses. You are not going to demolish all the 300. We will take only which is not in a standard. So that is why they are telling as many as 300 houses can be demolished. Every houses occupies 25 acre of land. Cost of demolishing will be 2000. So this is the first expenses. So the available acre we want to decide. What is the available acre? 25 acre of land is available to us. 25 acre of land is available to us. So this is the availability. This is the expenses. So this is also maximum 300 houses available. We will decide how many houses to be demolished. Second constraint, what it is? Lot size for single 1-story building, 2-story building, 3-story building, 4-story building. In your language, 1 bedroom, 2 bedroom, 3 bedroom, 1 BHK, 2 BHK, 3 BHK, 4 BHK. It takes 0.18 acre, 0.28 acre, 0.4, 0.5. Because if it is 1-story building, it is 0.18. If it is a 2-story building, 0.28. 3-story building, 0.4. 4-story building, 0.5 acre respectively. We have to give, suppose 100% is given. 100% of land is given to me, where 15% will goes to what? Street, open space, utility for other things. So the remaining 85% will be going for this 1-story, 2-story, 3-story, 4-story. Do you understand the first two conditions? Do you understand the first two conditions? I will work this problem bait, but do you able to understand first what is given? If you talk something, I can. If you want, I shall repeat.
Can you repeat?
First constraint, they are telling 300 substandard houses. You are having only 300 houses in your locality, but I am not going to demolish all the 300 houses. I will take only the houses which are not in the standard form. That only you are going to demolish. That is a decision variable. I come to that later. Second, each house occupies 25 acre of land. 25 acre lot. So available is 25 acre, where cost of demolishing per house is 2,000. We do not know how many houses we are going to demolish. That is also a decision variable. Available acre is 25. Available houses to demolish is 300. Cost of demolishing will be 2,000 per house. The lot size, once if you demolish, we want to construct the 1-story, 2-story, 3-story, 4-story building. 1-story building occupy 0.18. In 100%, 1-story building will be 0.18. 2-story building will be 0.28. This is what is that in 25 acre? In 25 acre of land, this will take 18% of 25, 0.28 of this, 0.4, 0.5 of this. So the remaining 85% is this. You can construct everything this in 85%. 85% of 25 acre. So the remaining 15% will goes to the street, open space, utility, etc. Is this clear?
Yes, sir.
I will write each and everything. You first read out the question. If it is delayed, not an issue. In a new development for a 3-story and 4-story unit, minimum 25% of the total should be allocated to this. In a new development, 25% in my total should go to, minimum 25% should go to. In the total means we are going to construct 1-story, 2-story, 3-story, 4-story, and then this is a total. In the total minimum, these two will be 0.25. Can you able to understand what are they telling? We don't know how many units I am going to construct in 1-story, 2-story, 3-story. That is what x1, x2, x3, x4. In which x3 plus x4 should be 25% in the total. Have you understood?
Yes, sir.
In the same way, single unit must be 25% of all. of all units double and of all units double and of all units and double unit must be 10%. So the same way in the total x1 just a minute. So in the total x1 plus x2 plus x3 of all 20% should go to whom? Single unit is x1, in which single unit is 20% in the total. The same way double unit is 10% of the total. So x1 plus x2 plus x3 plus x4, your double unit x2 should have 10% of the total. Have you understood this? The tax we want to maximize. So this is my profit. So this is my objective. So what is the profit? What is the tax they are taking for single, double, triple, and 4-unit, 4-story building? 1,000 rupees per building, 1,900, 2,700, 3,400. So this is my profit. We want to maximize the tax because question itself it says improve the tax base. So we want to maximize the tax. So the cost of construction per unit for single, double, triple, 4-unit will be, these are the expenses. For 1-story building it is 50,000, 2-story building 70,000, 3-story building 1,30,000, 4-story building 1,60,000 respectively. Finance will be arranged through the local bank, which can give $15 million or 15 million. How many units of each type should be constructed to maximize a tax return? Have you understood first what is the problem? I come to the problem now. We do not know how many units of 1-story, 2-story building to be constructed. Let A be a number of units of 1-story building. I mean single family homes. B is a number of units of double family homes. C number of units of triple family homes. D number of units of 4-family quadruple. X5 number of units to demolish. X5 means it is E. Number of units of homes to demolish. First, have you understood the decision variable? We want to maximize what? Tax rate. For 1-story it is 1,000. For 1 single unit it is 1,000. For 2 units it is 2,000. But I don't know how many units I am going to construct. Let it be A. Double story building B. Triple 2,700 C. 4-story 3,400 into D. All added together, we want to maximize the return tax. Subject to the first constraint. What is the first constraint? Acre used for, kindly use your, apply your mind, acre used for new home. Acre used for new home should be within what? Total available acre. Will I go beyond the available acre? Will I go beyond the available acre? This is the first constraint. Total available acre, that is your 85% will be taken for what? 85%, as I said, 15% will go to street, etc., open space. In 85%, we want to build 25 acre, but in the 25 acre, you are having already substandard houses. That is your E. I don't know how many houses I am going to demolish. So that is my decision variable E. Have you understood? This is your total available acre, 85% of 25 acre, where we have already got this substandard houses. That is a decision variable. That is a decision variable. So that has to be demolished. Where one story building will occupy 18% of A. This is 0.28 B. This is 0.4 C. The last one is 0.5 D. All added together, it should be within this. All added together, they should be within this. Have you understood this problem? I mean, have you understood this constraint? I am talking to you. Have you understood? Talk something. We want to maximize a tax return. You could have understood this. If you come to the first constraint, you want to demolish some houses. In where those houses are there? In 25 acre of land. In 25 acre of land, I am not going to build all your 1 story, 3 story, 4 story, because 15% 15% of 25 acre I should give to this open space street. So in 25 acre of the land which I am going to get through the demolishing of substandard houses, I can have only in 85%, not in 100%. So 85% where we will bring this 1 story, 2 story, 3 story building, where 1 story building will take a 0.18, but I don't know how many to construct. 2 story building will take 0.28 of acre. I don't know how many to construct. Like that, everything should be within 85%. Have you understood this?
Yes, sir.
Yes, sir. Yes, sir.
Next, I do not know how many units of houses I'm going to demolish. This is the next one. I don't know how many number of houses I'm going to demolish. So number of homes to demolish cannot exceed to demolish cannot exceed 300 substandard houses. I mean 300 units. So already we have decided maximum 300 houses can be demolished. So we don't know how many units to demolish. That is E. This is the second constraint. The first, whatever building we build, it should be within the available acre. Available acre means for what is the acre of land which is allocated for 1 story, 2 story, 3 story, 4 story, only 85%. So in 85% of 25 acre, where 1 story will take this, 2 story will take this, 3 story will take this, 4 story will take this, but I don't know how many to construct A, B, C, D. So all added together within this. Second case, number of units whatever I construct, it should be within, number of units whatever I demolish, it should be maximum 300. It does not mean that all the 300 houses to be demolished. You have to check which is not in the standard construction. Those houses can be demolished. So that is the second constraint. What is the third one? Third one is this. In a new development, already I discussed this. In the total of your A, B, C, D, the total of your A, B, C, D, single unit, triple and 4 story building, that is C plus D, should be how much? It should be minimum 25%. Am I right? Subdivision 3. What is subdivision 4? I'm sorry, and some more things are there. At least 25%, that is A plus B plus C plus D in a total single unit must have, that is A should have minimum 20%. Likewise, in a double unit, in a total of A plus B plus C plus D, double unit should have, that is B should have minimum 10%. Have you understood? And what is the
Yes, sir.
last one? And what is the last one? Construction cost and demolition cost should be within my 15 million. Construction cost and demolition cost should be within the given available fund. So construction cost and demolition cost should be within available budget. Available budget is 15 million. What is the cost of construction of a one-story building? 50,000, 70,000, 1,30,000, 1,60,000 plus cost of demolishing. Per house it is 2,000 rupees, I suppose. Per house 2,000. I do not know how many houses I am going to get demolished. So that into 2,000. So these two must be added. It should be within my, that is 50K plus 70K. You know, 50,000 times of A plus 70,000 times of B. 1,30,000 times of C. 1,60,000 times of D. And then demolishing. Per house it is 2,000. I do not know how many to demolish. So all are within my 15 million. So eventually, the units, whatever I construct, A, B, C, D, E, should be more than or equal to 0. Have you understood the problem?
Yes, sir.
This is the last problem of your LPP. Tomorrow I start decision theory. This is the last problem of LPP. Tomorrow I start decision theory. Loan policy model. These problems are having application in industry. That's why it took. Why specifically we are bothering about these problems? Because you have come to higher studies. So I don't like to dwell on the same fundamentals what you did in +2. That's why I slightly elevate these problems to post-graduation level. So you should have some idea of what kind of questions you can find in post-graduation level, or if you come to any project where how are they using these linear programming model in industry. So those questions you should know. That is why. So you should not be like a college, school students. You should elevate to the next level, enhance to the next level. The bank is in process of devising loan policy which involves maximum $12 million. Available fund is $12 million. The following table provides a pertinent data about available types of loan: personal loan, car loan, home loan, farm loan, commercial loan. Interest rate for personal, car, home, farm, commercial, which is given. Debt, you know, bad debt ratio means amount which is not recovered. 10%, 10% which is not recovered. Suppose if I issue 100 rupee, where 10% is not covered in personal. If I issue 100 rupee, where 7% is not recovered. If I issue 100 rupee for home, where 3% is not recovered. So this is 90% have recovered. Here 93% recovered. Here 97% recovered. So in all these cases, because this is given in percentage, because total is 100. Because total is 100. So this is 90% which is recovered in where? 140%. 93% recovered where? In the interest of 0.13. 97% recovered where? In 0.120. Do you first understand what it is given? You have issued the interest rate of 0.14. 0.14 where 10% is not recovered. So remaining 90% recovered in this interest rate, 93% recovered in car interest, 97% recovered in housing loan interest. Do you try to understand first what this table indicates?
Yes, sir.
Bad debt means it is not recovered. So where do you take this bad debt, the amount which is not recovered? Only from your profit. Am I right? See, these are the amount which I deducted from my interest. So this many amount which I got in this interest rate, this many amount which I got in interest rate. For an example, if I give 100 rupees where I got only 90% of 0.14, 93% of 0.13. So the remaining amount, the bad debts, where I should take, it should be taken only from my profit. So you should understand why are we why I'm telling this. Otherwise, where will you take this bad debt? You are running some business. You are running some business. You have obtained some amount. The loss is also there. So how do you compensate the loss? The loss can be compensated only from the profit what you earned. Otherwise, you cannot see what is your net return. I should subtract all my expenses, loss, whatever is left with me, that is my profit. That is what they are trying to do with the loan policy model. Now, total funds, you know, it is 12 lakhs. $12 million. Come to the rest of the question. Bad debts are unrecoverable. Very clear. If it is not recoverable, what I should do? I should take that bad debts only from the profit what I earn and produce no interest revenue. Competition with other financial institute requires that bank allocate minimum 40% to whom? Farm and commercial. So 40% I should give to farm and commercial because of competitive financial institutions are there. To assist the housing industry in the region, home loans must be equal to minimum 50% of home, personal, car, home loan. The last problem it was in the total, but here he says 50% only with what? Car, personal and home loan. Bank also have stated the policy of not allowing overall ratio of bad debts loans to exceed. So maximum 4% you can allow. Maximum 4% of bad debts you can allow in the bad debt ratio. So these are the constraints which are given to us. So what I want to do, we want to maximize the return. We want to maximize the return of whatever loan I give. So maximizing return, before getting into the problem, we want to decide the decision variable. What is personal loan? Let P be a personal loan. Amount which is given in dollars. Amounts which is in $1 million. What about next one? C is a car loan. C is a car loan. It is also $1 million. And H is a home loan. It is also $1 million. Then farm loan. What is a farm loan? F. It is also given in dollars because total available dollars is 12 million. And then commercial loan. So commercial means I take COM or CM. This is commercial loan. It is also $1 million. what I want to do, we want to maximize net return. We want to maximize a net return. It is equal to total interest what you paid. Total interest what you paid minus bad debts. Am I right? We want to maximize the return so that it can be done only with in the total interest, whatever I paid, I should deduct this bad debts. Don't worry, this kind of questions will not come to exam. But these questions are very important for your professional courses like CMA, CFA, CPA, or any MBA. It will play a vital role. That's why I just give you some introduction on this. So what is the total interest? Total interest is equal to interest rate where I should multiply this amount what I recovered, bad debts. Everything is given in percentage. So the total interest what I get in, as I said, in 100 I gave, where I don't get 10%. So where I don't get this, in my amount which I allocated for personal loan is 0.140. In 0.140, I got only 90%. 10% is not required. So 90% is the total interest which I got. But I don't know what amount I should allocate in this $12 million. Let it be your P. Plus, what is the amount which you got in the given interest? In 0.30, in the given 100, I don't get 0.7. I mean, I don't get 7%. So 100 minus 7, which I don't get in the interest which I gave for car loan. But I don't know what amount to allocate in this.
Sir, knowledge.
Well, what about the third case? See, before giving a loan, these are my assumptions. 10% I will not get, 7% I will not get, 3% I will not get, 5% I will not get, 2% I will not get. These are all my assumptions. So with this assumption, we should plan how much of fund should be allocated from $12 million to personal, car, home, farm, and commercial to maximize the return. That's it. Have you understood the problem? I forecast. So in 100, 3% will not be recovered for home loan of how much which I gave in interest, 0.12. So in 0.12, I don't get this, but I don't know how many to allocate for home loan. Let it be H. What is the last case? I mean, last two cases. This will be plus 0.125, where I don't get 5%. So 95% I will get. The last case is 100 minus 2 times of CM. Have you understood this part? Have you understood this part? Just I solved what is the total interest. Now I want to go to the maximizing return. So maximizing return is equal to total interest minus. If you simplify, you will get 0.126 times of P. 126 times of P plus 0.1209 times of C. I mean, if you simplify this is 0.1164 times of H plus 0.11875 times of F. This is 0.098 times of CM. There I have to subtract this bad debt minus bad debt. What is a bad debt? It is 0.1, where it is given here, times of P. This many are not required. Already I told, this is the interest which I get. I want to take this bad debt. Where will I get? It will be taken only from the profit what I got. So this is the profit which I got. This is the return which I got. Where I want to subtract this bad debt. That is why we are again subtracting this. This is 0.07 times of C. This is 0.03 times of H. This is 0.05 times of what? F. This is 0.02 times of CM, which is equal to 0.026, 0.0509. It is 0.086. So this is my objective function. Subject to, what is the first constraint? The first constraint is how much fund is available to you in all the personal, car, home loan, farm loan, commercial loan put together. I got only $12 million. $12 million. So this is the available fund. I do not know how many to allocate for personal, car, housing, farm, and the rest. What is the second condition? Combining farm and commercial loan. Combining farm and commercial loan. How much is given? At least 40% of all loans. Okay, 40% of all loan means how do you combine? So you know the total is P plus C plus H plus F plus CM. This is a total. Where I want to allocate as F plus CM should be minimum 40%. Am I right? Have you understood? Number 3. Home loan. At least 50% of what? Home loan should be 50% of. At least 50% of what? Personal, car, and home loans. So you know X3, I mean home loan in the total of what? Personal, car, and home. It should be minimum 50%. What is the fourth one? Bad debt should not exceed of all. Bad debt should not exceed 4% of all loans. So how do you get this? What is the total? That is P plus C plus H plus F plus CM. Where bad debt are this. That is 0.1 times of P. 0.1 P plus 0.07 times of C, etc. What is the last one? 0.02 0.02 times of CM should be maximum 4%. Maximum 4% of all loans. So this is the last constraint. So what is your final thing? Your ABC, I mean PCHFCM must be more than or equal to 0. That is the last thing. Have you understood?
Yes, sir.
So eventually this PCHM should be more than or equal to 0. So this kind of questions will not come to your exam, will not take place in your examination. But why these questions are significant, I told you, because for advanced studies, you should take this kind of questions to troubleshoot, like CMA, CPA, CFA, or any advanced courses. If you take, these questions plays a vital role. So with this, today's thing, tomorrow I start decision theory. And these are all some theoretical questions. I'm sorry, wait a minute. In a 5-mark question or theory, you may get what is operations research. They may ask what is operations research, where it has been started. The Second World War only this OR has introduced. Because what is the objective of the problem was, by that time, they want to win the war. They want to win the war using the minimum available resources, that is men and material are very less. Because in the war, there will be a loss of men as well as material. So medicines, warships, airships, gun, weapons, gunpowder, everything, it is having very minimum. But objective of the problem to win the war. So it was slowly attracted by industrialist LIC, Tata Iron and Steel, Indian Railways, Indian Airlines, where they are using only this OR technique to optimize their returns. So by that time, as I said, they want to reduce the usage of these two, men as well as material, to win the war. In the same way, nowadays, we want to give a minimum investment with a more returns with a minimum risk. You are having the 4 types of investment in an industry. Public deposits. Public deposit means where do we use? Fixed deposit, reinvestment plan, or share market, or postal savings. These are all public deposits. Share market, in fact, it is a public deposit, but still it is having some risk of getting a return. But these are all the guaranteed return, where in government, if I invest in post office, say any Kisan Vikas or fixed deposit or reinvestment plan, where we will get a guaranteed return, whatever they promise in the certificate. But if I put the same money in share market, mutual funds, I do not know will I get the same money. It is all based on the value of the share, price of the share, dividend per share, risk of getting a return. So what is the balance sheet of the company in the last few years? Based on that, the people will go and invest on their particular share. So the balance sheet decides everything. PL and account, profit and loss accounts will decide. So we have to look at all these factors, then only we can go and invest. So this many parameters, this many constraints are there. So these constraints decides where will we give more investment so that we can get more returns. Have you first understood how are we using our operations research technique in my industry? Even in the last question, you can see we have given this many loans. We want to get back all these loans using this bad debt ratio. So it is also one such a model. We have been using this in real-time scenario. So that's why this was actually found in Second World War. In many cases, they have been using this. I don't like to put my energy on describing this theory. You just go through this. How are they using in Indian Railways, Indian Airlines, textile industry, applications of OR or scope of OR? This is a very important 5-mark question. It's an important 5-mark. Which one? The scope of OR will come in 5 mark in a theoretical side. So just go through it. I don't like to waste my energy on this production management, manufacturing, marketing, where we will, suppose if you have any queries, you can come with your questions tomorrow, I shall answer. And what is linear programming problem? This is another 2 mark question. This is another 2 mark question which you can get in exam. This was found by US military, UK military, this linear programming model. Now I shall go to decision theory after this. Please go through all these theoretical side. Let us meet tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.